Cool. So welcome, guys, to functions part 2. This is the second part of our functions video. We're going to continue to learn some more about functions. Make sure that you're continuing to take notes. It's going to be very important that you're feeling comfortable with all the words that we use today when you get to class tomorrow. So in this first part, in that first video, we very quickly kind of went over what makes something a function. And you should be able to identify a function by simply looking at the numbers. We said that as long as my input allows me to predict my output every time, then I'm going to have a function. Okay? Now, at the very beginning of that video, I told you that there were two ways that we know that something is a function. And the first was that idea that each input goes to one output. For example, a 3 as an input shouldn't give me a 7 sometimes, and a 14 sometimes, and a 19 some other times. Okay? I should be getting one input to one output. The second thing we said was the vertical line test, and we didn't get a chance to go into that in the last video. So I want to talk to you a little bit about that now. The vertical line test is important because our data is not always going to be given to us in terms of coordinates or a chart or a mapping diagram. It's also possible that our data can be given to us graphically. That is, when somebody shows me on a graph, and this of course is my x and my y axis, when somebody gives me on a graph something that looks like that and asks me, well, is it a function? Well, we don't have the data sitting right in front of us. We're not looking at numbers, so it's hard to tell if each x value is only leading to one y value. But we actually have a very simple way to do this, and I have a feeling that vertical line test is probably going to become your favorite way to identify functions, even more than input-output. And the vertical line test is very, very simple. It goes like this. Is there any vertical line, remember that a vertical line goes like that, is there any vertical line that I can draw on this picture where it will cross through my function more than once, where it will cross through my line more than once? So notice, when I draw this vertical line, it crosses through my function exactly one time right there, okay? Now, if I draw a vertical line over here, it crosses through my function exactly one time. And when I draw one here, it crosses through my function exactly one time. Is there anywhere on this picture where I could draw that vertical line that it would cross through more than one time? And the answer is no. No matter what vertical line I draw here, it's only going to hit my purple line one time. So let's look at this. Using the vertical line test, we're going to do a couple examples here. So we'll call this example A, and we'll call this example B. And let's draw a couple functions and figure out if they are functions. Let's draw a couple lines. So we're going to do one that looks like this. That's a straight line. We call a straight line linear. Is a linear function going to be passing the vertical line test, making it a function? A linear, let's see, oh, just once. Oh, just once. Oh, just once. Is there anywhere along that purple line where I will cross through the line more than once by doing it? And the answer is no. So this is passes the test, and because it passes the test, that makes it a function. Okay? Let's try another one over here. Let's do a heart. Let's draw a heart. Okay? Is a heart a function? Let's see. So I go with my vertical line test, and I'm drawing, uh-oh, I just had my first problem. Notice that that crosses the heart once there, and it crosses the heart once there, and that, because it is crossing more than once, fails the vertical line test. It fails the vertical line test, and so it is not a function. The reason why it's not a function goes back to understanding the x and the y axis. So this is our x-axis right here. And let's pretend that that's sitting on -4. Notice that when I plug in -4 as an x value, I get two y values back. I get this one, which is 0, and I get one up here, which is something like 5. So when I plug in -4, I'm going to get a 0 sometimes, and sometimes I'm going to get a 5. That's what makes this not a function. So the vertical line test is really a shortcut for mapping all the points out on our function and trying to decide whether or not there's going to be any inputs that are repeating. And in this case, that input, that -4 value, has 2 different y values that go with it, not a function. Let's do a couple here. Let's do C and D. C and D. And I'd like to know whether or not you think that each one of these is a function. Is my squiggly line and my happy face a function? Go for it. Cool. So the answer is that neither one of them is a function. This one is not a function. There are many places I could draw this vertical line where it would fail, but here's one example of a place. When I draw it there, I have a problem there, there, and there. It's crossing 3 different times, not a function. In my happy face, there are a lot of places that I could draw my vertical line that would work, but that's not what we're asking. We're asking, is there any possible place where we're going to draw this vertical line up and down that crosses through more than one place? And the answer is yes. Right through that eyeball there of our happy face, it's going to cross once there and it's going to cross once there. So this is also not a function. Cool. So that's more or less how the vertical line test works. So just to recap really quickly, we've walked through 2 ways of determining whether or not something is a function. We looked at the coordinates to determine if the inputs are leading to unique outputs. We talked about also the vertical line test just now. A couple of things I want to throw in there before we run out of time here. There's a couple of words that are really important when we're talking about functions. And those 2 words are domain and range. And domain is just a fancy algebra way of saying inputs, which, remember, is usually our x coordinate. And range is just a fancy way of saying outputs, or our y coordinate. So if I look at something like this, something like that, and I ask you to identify the domain and the range, it's going to look something like this. The domain is going to be the set of numbers that includes 0, 1, 2, and 3, because the domain represents the input values, or all of these values. Okay? The range is going to look like 5, 9, 11, 13. And those little squiggly lines just mean that it's a set of numbers you're giving me. You're about to give me a whole bunch of numbers. That's what that means. There's 2 rules when we write the domain and range that I want you to be aware of. We always write from smallest to biggest. And we don't repeat any numbers when we're writing a set. No repeat. Cool. So to give you an idea of what that's going to mean, let's look at a slightly weirder case right here. We're going to go 3 gives me 7, 2 gives me 7, 1 gives me 14, and -7 gives me 11. I don't know. Some mismatch of numbers here. When we're looking for the domain, if we think about our 2 rules, remember our rules were the numbers need to go in order, smallest to biggest, and the numbers should not be repeated. What do you think the domain is going to be here? Cool. So the domain should be -7, 1, 2, 3. These numbers are going to go in order from smallest to largest. Even though in the chart they look like they're going 3, 2, 1, -7, when I write them in my domain, when I write them in my set, we're always going to write them in order. And our range is going to look like what? Cool. So our range should look like 7, 11, 14. Yes, I know there were 2 7s here, but we don't repeat numbers when we're writing a set. We're only going to write that number once. Okay, so essentially what we're doing when we write a set is we're saying, these are all the possible answers. Well, I don't need to list 7 twice if I'm saying that these are all the possible answers. The possible answers are 7 or 11 or 14. Just as a real quick check, last little question I have for you here, and of course we'll continue to digest some of this information in class tomorrow, but is the thing I put up here, this XY relationship, is that a function? And the answer is yes, it's a function. Whenever I put in a 3, I know I'm going to get a 7 because there's nothing else in this input area that tells me otherwise. I don't see another 3 down here giving me some other number, so I can assume that every time I put in a 3, I'm getting a 7. When I put in a 3, I'm getting a 7. That's a function. When I put in a 2, I'm getting a 7. I can predict every time I put a 2 in here, I'm going to get out a 7. When I put in a 1, I'm getting out a 14. When I put in a -7, I'm getting out an 11. There's no repeating inputs, so there's no evidence that the function is not working. This is a function. So after watching part 1 and part 2 of this video, you should be able to identify a function, and you should be able to identify a function if I give you a chart, if I give you a mapping diagram, if I give you coordinates, or if I give you a graph. Any of those 4 things, you should be able to identify a function. Remember that this one uses the vertical line test, and the other 3, we're going to just look for those input-output values. And the other thing you should be able to do after this, after having watched both of these videos, is you should be able to locate and identify domain and range. So from watching these 2 videos, we have basically covered an entire class period's worth of information, which is going to really help us out since we've been doing iReady for the last couple of days. This is going to make sure that we don't get too far behind in our lessons. And I hope this went pretty well for you. We'll come back and we'll get back to work on Thursday. So I hope you guys have a good rest of your night, and take care.